In this video, we're going to work example problems related to the angles of a triangle. In particular, what we discovered about relationships between angles of a triangle using parallel lines. So in this section, we were officially introduced to a triangle, and then we studied angles of a triangle, both interior and exterior angles, and the relationships between these angles using parallel lines. So, okay. On the basis of the information given, determine the measure of the remaining angles of the triangle. So if the measure of angle A is 63 degrees and the measure of angle B is 42 degrees, then they're asking what is the measure of angle C? Well, we know that we proved a theorem that states that the sum of the interior angles of any triangle, no matter what kind, is equal to 180 degrees. So, and I say interior angles because we know that you can do a virtual extension of the sides of a triangle, and there's also exterior angles of a triangle. So if it has an angle that has one side as a side of the triangle and another side as one of these virtual extensions, that's called an exterior angle. These are exterior angles. But then the angles that are inside of the triangle, interior to the triangle, are interior angles. There's only 3 of those in each triangle. And so, once again, we proved a theorem that says that the sum of the interior angles of any triangle is equal to 180 degrees. So, we can take this angle plus this angle, is 105 degrees. So we know that angle C must make up the difference in going from 105 to 180. So what's 180 minus 105? Well, that's going to be 75. So the measure of angle C is 75 degrees. All right, if the measure of angle B is 39 degrees and the measure of angle C is 82 degrees, what must the measure of angle A be? So same idea. 82 plus 39 is 121 degrees. So what's the difference now between 121 and 180? $59. So the measure of angle A must be 59. That way, when you sum these 3 angles, you get 180. Okay, what if the measure of angle A is equal to the measure of angle C is equal to 67 degrees? Well, same idea. Just what is 2 times 67? 134. So now what's the difference between 180 and 134? 46. So the measure of angle B must be 46 degrees. Okay, what if the measure of angle B is 42 degrees and they tell us that the measure of angles A and C are equal? Well, okay, all we have to do here is say that, so we know one angle is 42 degrees, and then added to that is going to be 2 times some number. And that needs to equal 180. So 2x, subtracting 42 from both sides, 180 minus 42, 138, divide both sides by 2. So 138 divided by 2 is 69. So, but x was just the measure of angle A and the measure of angle C. So if you take 2 times 69 and then add that to 42, you'll get 180. Describe the auxiliary line or segment as determined, overdetermined, or underdetermined. Okay, so first draw the line through vertex C of triangle ABC. So, okay, it just says draw this line here, this auxiliary line. So it's just any line, just draw a line. There we go. So it's like if we were trying to prove something, or not even prove something, just maybe this is like based on an engineering problem or something. We had a triangle like this, and we introduced this line to try and do an analysis. Okay, would this line here be determined, overdetermined, or underdetermined? It would be underdetermined, because if all we drew is a line, if we just said there's a line that goes through point C, well, what line? There's an infinite number of lines that go through point C. We haven't fully described this line to where it's like one unique line, right? We could be talking about this line. Like, what line are we talking about? There's an infinite number of lines that go through point C. So in this case, it's underdetermined. Okay, through vertex C, draw the line parallel to AB. So, okay. All right, so this is like they're parallel. Is this overdetermined, underdetermined, or determined? This is determined, because it's like kind of like ideally constrained, because we know that there's one unique line parallel to it. So if you have a point that's off of a line, then there's one unique line that goes through that point that's parallel to that original line. That's the parallel postulate. So we could say, okay, this line is going through point C is parallel to line AB, and that's like fully unique. You can make that statement, and then you can start doing certain analysis, and everything you're doing is unique analysis, non-ambiguous analysis. So this would be determined. Okay, draw the line with M, the midpoint of segment AB. Draw segment CM perpendicular to AB. So, okay, we've got M is the midpoint of AB, and we know that the midpoint of any line segment, let me draw that a little more to the right. We know that the midpoint of any line segment is unique, right? There's only one point. All right. Draw CM perpendicular to AB, okay? So, oh, well, okay, we have point C here, okay? So there's CM, but it needs to be, oh, well, no, it's just segment CM, so it would end, if it's segment CM, then it ends, has endpoints C and M, okay? Draw that perpendicular to AB. So we'd have to do like this. You know, we can't do that. That's overdetermined. Overdetermined is when you add constraints that aren't possible to add. We can clearly see that there's no way we can construct a perpendicular to AB that goes through the midpoint of AB and also goes through point C. So the idea is that they gave us too many constraints, and that some of those constraints were conflicting. In that case, it's overdetermined, right? I couldn't give you this and say this is perpendicular. That's clearly not. We know you can use your protractor to get an estimation, right? Like let's say the midpoint was like right here. Well, then is that overconstrained? It's hard to say. We have to kind of do some more investigating. We could use our protractor and see maybe it's 89 degrees, but still we don't know for sure. We have to do some more investigating. But here we can clearly take out our protractor and see this is nowhere close to 90 degrees. So there's no way I could give you a constraint. This goes through point C, goes to the midpoint of AB, and CM is also perpendicular to AB. That's overconstrained or overdetermined. Okay, same type of question. Describe if we introduce this auxiliary line segment. Would it be overdetermined, determined, or underdetermined? So if we drew a line through vertex B of the triangle, draw line AB perpendicular to AC. Okay, so what they're saying here is that we have segment AB, but we want to think about line AB, so we can extend this out as line AB, okay? Now, with segment AC, we want to, by extending line AB, we can show like a segment AC being perpendicular to line AB. So that would have to be like right here, but we can't do that. So that's overdetermined. There's too many constraints. it's not too many constraints, but they're providing conflicting constraints. So overdetermined. All right, draw the line that contains A, B, and C. Well, these are three non-collinear points. We can't draw a line that contains three non-collinear points. That's too many constraints or conflicting constraints. Okay, the line that contains M, the midpoint of A, B. Yeah, you see, that's underdetermined, right? They're saying draw the line, move to the right a little bit, draw the line that contains the midpoint M. Draw the line, right? That implies this unique line that contains the midpoint M. Well, there's an infinite number of lines that go, that's all they tell us. There's an infinite number of lines that go through point M. That's the only information they gave us. If they said contains, that goes through point C and contains, and also goes through midpoint M, that would be nicely constrained or determined. So this is underdetermined. Okay, classify the triangle, which is not shown, by considering the lengths of its sides. So, okay, what if all sides of triangle ABC are of the same length? So if you have a triangle where all of its sides are the same length, we know that falls under the category of equilateral. That's an equilateral triangle. Okay, what if we have triangle DEF, and the length of side DE is 6, side EF is 6, and side DF is 8. Well, that means two of the sides of this triangle are the same length. That is an isosceles triangle. Okay, what if you have triangle XYZ and segment XY is congruent to segment YZ? Well, what does congruent mean in terms of line segments? That means they're the same length. So this means that this is an isosceles triangle. We can assume that they're saying that. So we have XY, YZ, XZ is not congruent to these two. We can assume. So this is isosceles. Okay. What if in triangle RST, RS is equal to 6, ST is equal to 7, and RT is equal to 8? So none of the side lengths are the same length for this triangle. That's a scalene triangle. Okay, classify the triangle, which is not shown, by considering the measures of its angles. So there's different ways of categories that triangles fall under, and there's different names, and a lot of these are intermixed. So if the context is you're talking about the lengths of the sides of the triangle, we just talked about different categories in that respect. Here, if the context is you're looking at the angles of a triangle, here's some more categories that we're gonna consider here. So what if all of the angles of a triangle measure 60 degrees of this triangle ABC? Well, okay, they're saying that every single angle of the triangle measures 60 degrees. So we know if all the angles of a triangle are of equal measure, then that means it's an equiangular triangle. However, every single equiangular triangle is going to have the angles be 60 degrees, because 60 times 3 is 180. There's no equiangular triangle that doesn't have the angles measure 60 degrees, each of the angles. Okay, in triangle DEF, the measure of angle D is 40 degrees, and the measure of angle E is 50 degrees. Okay, well, maybe this is an acute triangle. Well, actually, okay, let's come back here. You could call this equiangular, that's true, but also it falls into the category of an acute triangle, because all of the angles of the triangle are acute angles. So you could call it an acute triangle as well. Here, okay, maybe this is an acute triangle, but if 50 plus 40 is 90, and there's only one angle left, and the sum of all the angles go to 180, well, then the other angle F must be 90, and we know that any triangle that has a 90-degree angle in it is a right triangle. It's not acute, it's not obtuse, it's a right triangle. All right, in triangle XYZ, the measure of angle X is 123 degrees. This is going to be an obtuse triangle. If one angle of a triangle is obtuse, then it's an obtuse triangle. And if all the angles are acute, it's an acute triangle. Okay, what if you have triangle RST, and the measure of angle R is 45, measure of angle S is 65, measure of angle T is 70? Well, that's an acute triangle. All the angles are acute. suppose that for triangle ABC and triangle MNQ, you know that angle A is congruent to angle M and angle B is congruent to angle N. Explain why angle C must be congruent to angle Q. Well, we learned a corollary that states that if this is the case, then this must be the case. And it's a corollary that is directly related to the theorem of all of the angles of any interior angles of any triangle summed to 180. So the idea is, if you can think about it like this. So if we've got, one triangle like that, and then another, trying to make the angles kind of similar. Okay, so they're telling us that we've got triangle A, B, C, and M, N, Q. Okay, so, A, B, C, M, N, Q. All right, but they say that angle A is congruent to angle M and angle B is congruent to angle N. So just so we can make this clear, what this means is that you can kind of say this. As far as measures go, you could change this from M to A and B to and N to B, right? Just as far as measures go, just so we can see this clearly, right? And all we're left with is C and Q, which may or may not be congruent. We don't know, right? Okay, and so with that, we can say that A plus B, imagine I'm saying measures of angle A, measures of angle B, plus C is equal to 180, right? And then here, A plus B plus Q is equal to 180. Everything checks out so far. Okay, so let's subtract A and B from both sides of this equation. 180 minus A minus B, all right? Let's subtract A and B from both sides of this equation. Well, look, they both have the same measure. C and Q are both equal to 180 minus A minus B. So C is equal to Q. Suppose that T is a point on side PQ of triangle PQR. Also, ray RT bisects angle PRQ, and angle P is congruent to angle Q. If angle 1 and angle 2 are the angles formed when ray RT intersects segment PQ, explain why angle 1 is congruent to angle 2. Okay, so let's draw triangle PQR. Okay, so PQR. All right, so there's segment PQ. Also, ray RT bisects angle PRQ. Ray RT, so we don't have a T. Okay, what is point? T is a point on side PQ. Okay, and ray RT bisects angle PRQ. So, okay, angle PRQ, let's draw it. It bisects, so cuts it in half, and it's a ray. So we'll just draw it just going through. Let's see. It bisects it, so about right there. Okay, and this is point T. And it bisects this. So this and this are equal angles. Okay, and P is congruent with Q. So these are also congruent, but like they're not necessarily congruent to this. Okay, if angle 1 and angle 2 are the angles formed when RT intersects PQ, so this is angle 1 and this is angle 2. Explain why angle 1 is congruent to angle 2. Well, if that's the case, then these are right angles because you have the straight angle here, right? Okay, but how can we explain why this must be true? Okay, well, we can see here it's going to come from that corollary of if you have two angles of two triangles are congruent, then the third angle must be congruent. Because look, angle P is congruent to angle Q, and this angle is congruent to this angle. So these two triangles have two pairs of congruent angles. So that means angle 1 must be congruent to angle 2. That's it. It's based on that corollary that we just worked with in the previous problem. And we can also see, they didn't ask us this, but again, these are going to be right angles as well. Because if they're equal and this is a straight angle, then call the measure of angle 1 the measure of angle 2 x. 2 times x is going to be equal to 180. Okay, so we have this figure here, this triangle, and a line representing one side of the triangle and another line that goes through a vertex here. And they're saying that this line is parallel to this line. So these two are parallel. Okay. So with that, given that the measure of angle 3 is 50 degrees and the measure of angle 4 is 72 degrees, find the measure of angle 1, the measure of angle 2, and the measure of angle 5. Okay, well, we know it was this setup here that was used to prove the theorem that the sum of the interior angles of any triangle are equal to 180. So, but let's try not to reference that. Let's just look at this, assuming we don't have that knowledge yet. Okay, so if the measure of angle 3 is 50, and the measure of angle 4 is 72, okay, so this is 72. All right, well, we know that this is 72 then, opposite interior angles with AB being a transversal and J and K the parallel lines. Okay, let's see. Measure of angle 3 is 50. Okay, this is 50. Well, we have a straight angle here. 72 plus 50 plus the measure of angle 6 is going to need to be 180. So 72 plus 50 is 122. 180 minus 122 is going to be 58. So this is 58. Well, that means that this is 58. Okay, but now we've got angle 1 is going to be 180 minus 58. $122. So there you go. There's angle 1, angle 2, and angle 5. Okay, so angle 3 is 55. Angle 2 is 74. So what is the measure of angle 1, measure of angle 4, measure of angle 5? Well, you know, we could do the sum of the interior angles of a triangle equal to 180 to get angle 4, but let's try and not use that. So, okay, measure of angle 1 is, we can see, is going to be 180 minus 74, straight angle here. So 106. Okay, we've got opposite interior angles here. This is 74. Now what we could do is we could see that this is a straight angle and get angle 5, but we could also do that angle 5 plus angle 3 is equal to angle 1, the measures, opposite interior angles there. So we have the measure of angle 5 plus the measure of angle 3 is going to have to be equal to 106. So 106 minus 55 is 51. So 51. And let's see, that should be, so 51 plus 55 plus 74. Let's check that. $180. There we go. Okay. Now the measure of angle 4 is going to be 51. Opposite interior angles. Okay, measure of angle 1 is 122.3 degrees. Measure of angle 5 is 41.5 degrees. So that means angle 4 is going to be 41.5. And we can see that. So 41.5 plus the measure of angle 3 is going to be 122.3, opposite interior angles. So measure of angle 3 is, you have 122.3 minus 41.5. So 80. So 80.8 is the measure of angle 3. Okay, let's see. 180, straight angle here, 180 minus 122.3 So $57.7, and then we have opposite interior angles here. So we've got measure of angle 2, measure of angle 3, and the measure of angle 4. Okay, given that MN, segment MN, is perpendicular to segment NQ, and given the angles shown, find X, Y, and Z. Okay, so let's just start filling in values, any values that we can, and then we'll see what that reveals. So we can get this angle here. That's going to be 90 minus 65. So this is 25 degrees. Okay, this is X. Let's see. Okay, yeah, we can get this angle here because we know the sum of the angles of a triangle, interior angles equal 180. I think they're allowing us to go ahead and use that theorem now. So 65 plus 43. Now 180 minus 108 is going to be 72. So this is 72. And therefore, this angle here is 72 vertical angles. But now we know the sum of all of the angles going all the way around a point is equal to 360. So we have 2x plus then 72 times 2 is going to be what? 144 is equal to 360. So 360 minus 144 is 216. So 2x is equal to 216. So x is equal to 216 divided by 2 is 108. Okay. Now we have this triangle here, triangle RMP. So we can say 108 plus 28 plus y is equal to 180. So 108 plus 28 is 136. So subtracting 136 from both sides is 44. So y is equal to 44. Okay, now we've got also have 25 plus 108 plus z needs to be equal to 180. So 108 plus 25 is 133. So now 180 minus 133 is 47. So z is equal to 47. Okay, given that segment AB is parallel to segment DC, so these two are parallel, and ray DB bisects angle ADC. So here's ADC, here's ray DB, and ray DB bisects this angle. So that means angles 1 and 2 are congruent. All right, and then the measure of angle A is 110 degrees. Find the measure of angle 3. Okay. So we've got these two parallel lines here that go through segment AB and DC. And then we've got a transversal here that cuts across those two lines. All right. Well, we see that angles 2 and 3 are with respect to that, are alternate interior angles. So angle 3 and angle 2 are congruent, which means that angles 1 and 3 are congruent. So with that, we've got this triangle ADB. So we can say that 110 plus the measure of angles 1 and the measure of angle 3, since they're the same, we can just say 2x, 2 times whatever the measures of each of those angles are, is equal to 180. So subtracting 110 from both sides, 180 minus 110 is going to be 70. Okay, dividing both sides by 2, you're going to get that x is equal to 35. So the measure of angle 3 is 35 degrees. Okay, so, once again, AB is parallel to DC, and DB bisects ADC, and the measure of angle 1 is 36 degrees. Find the measure of angle A. Well, once again, these are going to be congruent, 2 and 3, but then that means they're congruent to 1, so this is 36 degrees. So what we've got is the measure of angle A, if this is x plus 2 times 36 is going to need to be equal to 180 because of triangle ADB. So 36 times 2 is going to be 72. So 180 minus 72 is 108. Okay, given triangle ABC with B, D, E, and C all being collinear in this order, and given that the measure of angle 3 is equal to the measure of angle 4 is equal to 30 degrees, and the measure of angle 1 is equal to the measure of angle 2 is equal to 70 degrees, find the measure of angle B. Okay, so this is 30 degrees. This is 30 degrees. This is 70 degrees. And this is 70 degrees. Now find the measure of angle B. All right, so let's just start filling in information here. But we can get this angle right here because we've got two angles of this middle triangle. So 70 plus 70 is 140. And then 180 minus 140 is 40. Okay. We've got a straight angle here. So 1 and 5 are supplementary, and 2 and this angle are supplementary. So 180 minus 70 is 110. Okay, and this would be 110 as well. Okay, so now we can get the measure of angle B because we've got two angles of a triangle, this triangle ABD here. So 110 plus 30 is 140, and then 180 minus 140 is 40. So the measure of angle B is 40 degrees. Okay, so same setup, but now the measure of angle 1 is 2x, and the measure of angle 3 is x. So now find the measure of angle B in terms of x. So, okay, well, 1 and 5 are supplementary, so this is going to be 180 minus 2x. So we can say that the measure of angle B plus x plus 180 minus 2x is going to be equal to 180. So the measure of angle B plus x plus subtract 180 from both sides. X minus 2x is minus x. So the measure of angle B is equal to x. All right, so now they're saying triangle ADE, you've got the measure of angle 1 is equal to the measure of angle 2 is equal to x. And the measure of angle DAE is equal to x divided by 2. Then find x, find the measure of angle 1 and the measure of angle DAE. Okay, so since 1 and 5 are supplementary, you've got, and then here, same thing. Okay, now we can, let's do, so if we sum the angles of this triangle DAE, x plus x plus x divided by 2 is going to be equal to 180. So now let's multiply this entire equation by 2. So 2x plus 2x plus x is equal to 360. So 2x plus 2x plus x is 5x. Okay, so let's see. 360 divided by 5. 5 times 7. So x is 72. Okay, so there's x. 72 degrees. Okay. And, well, that's the measure of angle 1 as well, right? That's just x. Okay, now the measure of angle DAE is just x divided by 2. So 72 divided by 2 is 36. So measure of angle DAE is 36 degrees. Okay, triangle ABC, the outer triangle. And then, so with that, you have the measure of angle B is equal to the measure of angle C is equal to x divided by 2. And the measure of angle BAC is equal to x. So they're saying this angle, I guess you could say angle A, is equal to x. Find x, find the measure of angle BAC, which is going to be equal to x, and the measure of angle B. Okay, well, we've got this outer triangle here. We can say that x divided by 2 plus x divided by 2 plus x is equal to 180. So we've got one equation, one unknown here. Let's multiply this entire equation by 2. So we're left with x plus 2x is equal to 360. So x plus 2x is 4x. Okay, that means that x is going to be equal to 90 degrees. So this is a right angle. Okay, so if x is 90, then the measure of angle BAC is 90. And then the measure of angle B is just 90 divided by 2. And same with the measure of angle C. Measure of angle B, right? X divided by 2. 45 degrees. Hello. Consider any triangle and one exterior angle at each vertex. What is the sum of the measures of the 3 exterior angles of the triangle? Okay, so let's just draw a general triangle here. Okay, now, so we learned that there's 3 interior angles of a triangle where the sides are, at each, associated with each vertex. The sides of the triangle that come off of each vertex are the sides of the angle. But then there's 6 exterior angles. So the idea is you do a virtual extension of the sides past each vertex. Okay, now what results is at each vertex there's these 3 angles here, but only 2 are considered exterior angles because you only consider an exterior angle as one of these angles that has one side that's on the triangle. So this has 2 sides that are the part of the virtual extension. So that's not an exterior angle. I mean, that's just a vertical angle to the interior angle. So this is an exterior angle, this is an exterior angle, this, and this. So each vertex has two exterior angles associated with it. Now, they're asking, consider one exterior angle at each vertex. What is the sum of the measures of the three exterior angles of the triangle? So I guess they're saying that we can say this is 1, pick another one, 2, pick another one, 3. Whatever we want. So what's going to be the sum of these? Okay, well, to figure this out, we can try and use a corollary that we learned. So some more notation is that. So each exterior angle associated with it is an adjacent interior angle, which is the vertex angle it's at, and two non-adjacent interior angles. So the non-adjacent interior angles for angle 1 would be this angle and this angle. Okay, and so for any exterior angle, whatever exterior angle you have, either of these two, whatever, the measure of that exterior angle is equal to the sum of the measures of its two non-adjacent interior angles. So we can call this, let's say this is A, this is B, and this is C. Okay, so we know that, for example, 1 is equal to A plus B. I'm not going to write measures of angle 1 just to keep it concise. Okay, so we know this is true. Let's try and use this. Okay, so let's do this for the other angles, the exterior angles. So 2 is equal to B plus C, and 3 is equal to A plus C. Those are three true statements based on that corollary. Okay, but now we also know, let's go ahead and write this, that A plus B plus C is equal to 180. Okay, but now what we're trying to figure out is what is 1 plus 2 plus 3. That's what we're trying to figure out. So let's write this. Let's substitute in what we have here. So A plus B plus B plus C plus A plus C is equal to, I guess, X. We'll call that X. That's what we're looking for. Okay, so X is equal to, we've got 2A plus 2B plus 2C. All right, well, let's factor out a 2 here. A plus B plus C. Okay, well, A plus B plus C is 180. Let's substitute that in. Okay, 2 times 180 is 360. There we go. And that's completely general. We just randomly picked any exterior angles at each vertex. So we just proved that the sum of the measures of any three exterior angles of a triangle, as long as they're each of the ones you pick are at their own vertice, is 360. Okay, given right triangle ABC with right angle C, the measure of angle 1 is 7x plus 4. The measure of angle 2 is 5x plus 2. Find x. Okay, well, we know that the acute angles of a right triangle are complementary. We know that the two non-90-degree angles of a right triangle have to be acute, because if you had one of these was obtuse, then you add that to 90, that's greater than 180, so it wouldn't make sense for the other angles. So we know the two non-90-degree angles of a right triangle are acute, but we also know that they're complementary, because if this is 90 and the sum of the angles is going to add to 180, then that means these two must add to 90. So these two are complementary. So, okay, there we go. We know that 7x plus 4 plus 5x plus 2 needs to be equal to 90. Now we can just solve for x. So 7 plus 5 is 12. 4 plus 2 is 6. Subtract 6 from both sides. Okay, divide both sides by 12. You've got x is equal to 7. And that would be degrees. Okay, if the measure of angle 1 is equal to x, the measure of angle 2 is equal to y, and the measure of angle 3 is equal to 3x. Solve for x and y. Okay, well, we know x plus y is equal to 90. We can start there. All right, now we know that also the sum of angles 2 and 3 is going to be equal to 180, right? These two are supplementary straight angles, so let's put 3x plus y is equal to 180. Two equations, two unknowns. And we can just go ahead and straight from here subtract these two equations. X minus 3x is minus 2x. Y minus y is 0. 90 minus 180 is minus 90. So x is equal to 45 degrees. Okay, so now plugging that in here, you've got 45 plus y is equal to 90. Subtracting 45 from both sides, you have y is also equal to 45. Okay, measure of angle 1 is equal to x. Measure of angle 2 is equal to x divided by 2. Find x. Well, just x plus x divided by 2 is going to be equal to 90. These two angles are complementary. So multiply this entire equation by 2. You've got 2x plus x is equal to 180. So 3x is equal to 180. So x is equal to 60 degrees. Okay, measure of angle 1 is x divided by 2. Measure of angle 2 is x divided by 3. Find x. It's the same thing. This is just algebra. Angles 1 and angles 2 are complementary. Okay, so multiply this entire equation by 6. So 6 divided by 2 is 3. 6 divided by 3 is 2. 90 times 6, 9 times 6 is 54. Okay, 3x plus 2x is 5x. So x is equal to 540 8 times 5 is 40. So 108 degrees. Okay, given the measures of angle 1, 3, and 5 are these expressions of x related to the angles of this triangle here, find x. So, we could just look at the fact that, like, measure of angle 1 and 2 are those are supplementary angles, 3 and 4 are supplementary. But it would be good practice to try and think about relationships between exterior angles and the interior angles of a triangle as well, so we don't forget about it. So, okay, we know that the exterior angles, any exterior angle of a triangle is going to be equal to the sum of the non-adjacent interior angles. And this is definitely angle 1 is an exterior angle for sure. So why don't we just go ahead and say that measure of angle 1, 8 times x plus 2, is equal to the sum of these two. Again, we could have just, started with call like angle 2 y and then solve for y in terms of x, since these two must sum to 180, but let's try and think about the exterior angle relationships. All right, so 8x plus 16 is equal to 5x minus 3 plus 5x plus 5 minus 2. So 8x plus 16 is equal to 10x plus 2 minus 2, because 5x plus 5x is 10x, minus 3 plus 5 is 2. Okay, so 8x plus 16 is equal to 10x. subtract 10x from both sides, add 2x to both sides, divide both sides by 2, so x is equal to 8. 8 degrees. Okay, so again, let's try and use the fact that like the measure of angle 4 is going to be the measure of angle 5 plus measure of angle 2, things like that. So, okay, so now we're given these, the measure of these angles as expressions of x or y. So once again, let's just try and use, we're trying to solve for x, y, and the measure of angle 5. Let's just try and use the relations of exterior angles to interior angles. So measure of angle 4, 2x minus y minus 40, we know is going to be equal to the measure of angle 2 plus the measure of angle 5. But they don't give us the measure of angle 5, so okay. Well, in that case, let's just go ahead and do, so, okay, 1 and 2 are supplementary. So x plus 4y is equal to 180. 3 and 4 are supplementary, so 2y plus 2x minus y minus 40 is equal to 180. So 2y minus y is equal to y plus 2x, and then you add 40 to both sides, you get 220. So we've got, let's see, 2x plus y is equal to 220. So now let's multiply that first equation by 2 is equal to 360. So we've got 2x plus y is equal to 220. Okay, now let's subtract these two equations. 2x minus 2x is 0. 8y minus 7, or 8y minus y is 7y. 360 minus 220 is going to be 140. So divide both sides by 7. You get y is equal to 7 times 20 is 140. Okay, now plugging y back into this first equation, so you have x plus 4 times y is equal to 180. So x plus 20 times 4 is 80 is 180. Subtract 80 from both sides, you get 100 degrees. Okay, now that's x and y, but what is the measure of angle 5? So we just need to sum the, so measure of angle 2 plus measure of angle 3 is 4y plus 2y. Okay, then plus the measure of angle 5 is going to be equal to 180. So 6y plus the measure of angle 5 is equal to 180. So 6 times 20 is what? That's 120. So 120 plus the measure of angle 5 is equal to 180. So 180 minus 120 is equal to 60. The sum of the measures of two angles of a triangle equals the measure of the third largest angle. What type of triangle is described? Okay, so this is kind of confusing. They're not saying the third largest angle, like the smallest angle of the triangle. That would make no sense, right? The sum of the measures of the two angles of a triangle is equal to the measure of the smallest angle. The third angle is being the largest. Well, we know that's going to be a right triangle. A right triangle is unique in that if you sum the two acute angles, you get 90, right? The sum of the measures of the acute angles is equal to 90. So they're talking about a right triangle here. That's the only case where this happens. Draw, if possible, an isosceles obtuse triangle and an equilateral right triangle. Okay, well, for sure, part B is not possible because you can't, we're going to learn that you can't, there's no way that the hypotenuse, which is the side opposite the right angle, is 100%, no matter what, going to be larger in length than the two legs, A, B, and C. we're going to see that we're going to come up with the Pythagorean theorem, a squared plus b squared is equal to c squared. But a and b can't be 0, right? Or you wouldn't have a triangle. So c is going to have to be bigger than a and b. So this is not possible. What about an isosceles obtuse triangle? So what does isosceles mean? Well, okay, well, first of all, just to make sure we're clear, equilateral, what they're talking about is all sides have equal lengths. And then right, that means there's one 90-degree angle. So they're saying a triangle that has one 90-degree angle and also has all sides of equal length is not possible. Okay. Now, what about an isosceles obtuse triangle? Okay, obtuse means there's one obtuse angle in the triangle, and there's only going to be one. You can't have two obtuse angles in a triangle, right? Because if you have, like, obtuse means you have an angle that's greater than 90. So, okay, if you do, you can't have two 90-degree angles in a right triangle because then the third angle would have to be 0. So if you can't have two 90-degree angles, you definitely can have two obtuse angles. So there's going to be one obtuse angle, and isosceles is these two are talking about the angle relationships in the triangles. These two are talking about the side length relationships. So isosceles means there's two equal side lengths. Okay, and I think that would be okay because you could do, I don't think you could have an obtuse triangle with all three equal angles, angular, but you could do an obtuse triangle. So there's the equal side length, these two, right? Exact same, okay? So these are the same length. This is the obtuse angle, and then this can be whatever length you want. So there you go. Yeah, you could do that, but this is not possible. Okay, draw, if possible, a right scalene triangle and a triangle having both a right angle and an obtuse angle. Well, part B is just like I mentioned for the previous problem, is not possible because you can't have, how could you have a right angle and an obtuse angle? Those two angles would be, their sum would be greater than 180, just those two angles. So then the other angle would have to be negative. Doesn't make any sense, right? So this is, I'm not even going to try and draw that. But the right scalene triangle, so we know what right means, but what does scalene mean? Scalene means that none of the side lengths have the same length. So, okay, yeah, we should be able to do this. So all we got to do is just, okay, there's one side length. There's another side length. Those two definitely don't have the same length. But for a triangle, a right triangle, again, I mean, I'm kind of getting ahead of what we're. I mean, I don't want to get too far ahead, but we're going. I can tell you that the hypotenuse of this side of a right triangle is going to be larger in length than the two legs. So these two, A and B, for sure, we can see visually don't have the same length, but 100% side C is not going to have is going to be larger in length than A and B. So that's scalene. Because again, we're going to find that A squared plus B squared is equal to C squared. So C has to be greater than A and B because A and B can't be 0, or else that wouldn't make any sense. Okay, along a straight shoreline, two houses are located at points H and M. The houses are 5,000 feet apart. A small island lies in view of both houses with angles as indicated. Find the measure of angle I. So yeah, just to give you some background here, you might wonder, well, how could you know these angles? You know, I get how they could measure the distance here, but how could you know these angles? Well, those survey measuring devices, you know, that you see surveyors using with the, you know, they're looking through right here. Those they can measure angles very accurately between like far off features. And so that's what they do. They get these angles, but they can't measure. These lengths are hard to measure, right? But they can like view the island at a distance, get angles, and then use angle relationships to solve triangles. So we're not solving triangles here, but like in trigonometry, we learn how the law of sines, law of cosines allows you to, if you've got angles and side lengths of triangles, you can solve triangles. We learn in trigonometry how to solve any kind of triangle. So it's pretty cool. But here they just want to know what this angle is. So, okay, let's see. Well, we know that we've got a straight angle here, so we can say 180 minus 67 is this angle. So that's 113. And there you go. 113 plus 23 plus the measure of angle I needs to be equal to 180. So 113 plus 23 is 136. 180 minus 136 is 44. So the measure of angle I is 44 degrees. All right, an airplane has leveled off, is flying horizontally at an altitude of 12,000 feet. Its pilot can see each of two farmhouses at points R and T in front of the plane with angle measures as indicated. So, this is kind of unrealistic. How could the pilot know these angles? But you could have angle measuring devices in the plane that can get angles of features. Okay, just note that they've got devices that can measure angles of these far off random features. Okay, so these got these two farmhouses at points R and T in the front of the plane with the angle measures from the horizontal shown here. So now find the measure of angle R. All right, so we can draw this. That would be a right angle. That's 12,000 feet. Okay, so we've got this. We could assume that these two lines are parallel, just pointing that out. Maybe we can use alternate interior or exterior angles. So we've got this two parallel lines cut by this transversal. Are these alternate interior angles? Well, okay, what about this transversal here? Yeah, these are alternate interior angles. This is 37 degrees. Okay, but now we can see that if we take 65 minus 37, we get 28. So this is 28 degrees. And so there we go. 28 plus 37 is 65. And then 180 minus 65 is going to be the measure of angle R, because we can sum the angles of this triangle here. 115. So the measure of angle R is 115. On a map, 3 Los Angeles suburbs are located at points N, P, and B. Newport Beach, Pomona, and Burbank. With angle measures as indicated, determine the measure of angle N and the measure of angle P. So maybe you could fly over this and take some images and get these angles, right? You could think about it that way. So, okay, well, the sum of the measures, does it say it's a right triangle? It doesn't even matter. These are going to sum to 180. So 33 plus 2x plus x is equal to 180. 33 plus 3x is equal to 180. Subtract 33 from both sides. $147. So divide both sides by 3. X is equal to 147 divided by 3. 3 times 4 is 12. 9 times 3 is 27. So 49 degrees. So the measure of angle N we can see is going to be 49 degrees. And the measure of angle P is going to be 2 times 49 degrees, which would be what? So 50 times 2 is 100, but subtract 2 from that, it's going to be 98 degrees. The roof line of a house shows the shape of right triangle ABC with measure of angle C equal to 90 degrees. If the measure of angle CAB, so the angle A here, well, not angle A, this would be angle A, so just this up here, is 24 degrees larger than the measure of angle CBA. So they're saying, like, if this is x, then this is x plus 24. Then how large is each angle? So you could just think about maybe, what roof looks like this. Well, no, it's like a projection onto, if you look straight ahead at this house and took a picture and then just did like an outline, like a pure straight view, maybe that the outline is something like that. Right? You could think about it would be like the house is, like this, and then the roof does, you see, from a straight view, just looking at straight this way, it makes that shape, you see? So, okay. Well, okay, we know that this is a right triangle, these two angles are going to be complementary. I mean, we could just sum all these to 180 and like take this plus this plus this and get 180, but you could also just look at it and say the two acute angles of a right triangle are complementary. So they sum to 90. So 2x plus 24 is equal to 90. 90 minus 24 is 66. So x is equal to 33 degrees. So, okay, the measure of angle B, measure of angle CBA is 33 degrees. And then the measure of angle CAB is 33 plus 24. 57 degrees. A polygon with 4 sides is called a quadrilateral. Consider the figure and the dashed auxiliary line. What is the sum of the measures of the 4 interior angles of this or any other quadrilateral? All right, so here's this quadrilateral and then the dashed auxiliary line. And just to point out, so you could add this auxiliary line and justify it because we know that there's one unique line that goes through 2 points, right? So you could state it that way. Goes through points, one unique line going through points M and P. All right, but so we've got this quadrilateral. It's got 4 sides. Now, what is the sum of the measures of the 4 interior angles of this or any other quadrilateral? So what is this angle plus this angle plus this angle plus this angle? That's what they're asking. So, okay. Let's think about this. Well, we've got these 2 triangles here. This triangle okay, and then this triangle. So what we could do is we could say, let's see, we could do like this is M1, this is M2, this is P1, this is P2. Okay, so we know that N plus M1 plus P1 is equal to 180. Okay, then we know that Q plus M2 plus P2 is equal to 180. Okay, now these are both equal to 180, so maybe we can set them equal to each other. N plus M1 plus P1 is equal to Q plus M2 plus P2. Well, no, let's not do that. Let's sum these two. Let's sum these two. So N plus M1, like we know that. So if we add N plus M1 plus P1 to Q plus M2 plus P2, what is that going to be equal to? Well, we're just summing 180 and 180, right? That's all we did. So, okay. But M1 plus M2 is just M, right? And P1 plus P2 is just P. And we see that we can rearrange this. Plus Q plus right? M1 plus M2 is M. P1 plus P2 is P. So N plus M plus Q plus P is equal to 360. There you go. N plus M plus P plus Q is going to be 360.